Topic for today is section formula. This can come in section A, it can go in section B, nothing is fixed. At times it can come mixed, like you may have one question independently on section formula and you may have a little blend of section formula with another topic, equation of a line. Okay, let us see the different formulae in this topic. Consider segment AB. Consider segment AB. P is a random point on AB. Now naturally, P divides segment AB in some ratio. Like say if this is 5 centimeters and this is say 10 centimeters. So ratio would be 5:10, that is 1:2. So let P divide segment AB in the ratio m:n in general. Okay, in general, point P divides segment AB in the ratio m:n. Now we wish to find the coordinates of point P under the given conditions. So A is taken as x1, y1. That is x coordinate of the first point and y coordinate of the first point. So A is called as x1, y1. B will be taken as x2, y2. Now P is a point which is dividing segment AB in the ratio m:n. So we need to find the coordinates of point P. So P will have two coordinates, x coordinate and the y coordinate. Now before I give you the formula, in case you have forgotten the basics, I will have a quick recap. The way we have name and surname which defines us completely, similarly any point has x coordinate and y coordinate. So there is a point Z, 7, -9. So this is known as x coordinate and -9 would be known as y coordinate. X coordinate is also known as abscissa and y coordinate is also known as ordinate, and together they are known as coordinates. So this is 7 is x coordinate, -9 is y coordinate. X coordinate is also known as abscissa, y coordinate is also known as ordinate, ordinate. Okay, this is the way we can fix the point in the xy plane. Now coming here, P is a point which is dividing segment AB in the ratio m:n. So here the order is very important. If I have to read this diagram, I would say point P divides segment AB in the ratio m:n, or point P divides segment BA in the ratio n:m. Okay, and remember m should always be on the side of x1, y1, otherwise the formula will not work. So this is an important tip. M should always be on the side of x1, y1, and then n should be on the side of x2, y2. So under such conditions, we write like this: px, p suffix x. So we will hereafter read this as px. Px means x coordinate of point P. This would be mx2, m into x2, crisscross. We jump the border. mx2, like this is part 1, this is part 2. So we jump mx2 plus nx1 upon m plus n. P suffix y is my2 plus ny1 upon m plus n. So you should not get confused between x and y. When we are dealing with px, you will have x1 and x2 coming in the picture, y will not come. And when you are dealing with py, you will have y1 and y2 coming in the picture. So this is known as section formula. First one, this is known as section formula. So once again, px will be mx2, m into x2 plus n into x1 upon m plus n, and p is py. Now we call it py, that is the y coordinate of the point p, will be my2 plus ny1 upon m plus n. So comfortable till here? Now let us see the other two formulae in this topic. So once we complete all the three formulae, then we will start with the numericals. Now you have something known as midpoint formula, which is actually a special case of section formula, but you need not show section formula. You can directly use the midpoint formula. Now let this be, say, A, x1, y1. Let this be, say, B, x2, y2. Now P is our midpoint here. P is the midpoint. So if I just try to show you the connection quickly, what would be the ratio AP is to PB? 1:1. Suppose ये 7 है, ये भी 7 है, तो ratio is 7:7, that is 1:1. So if I put m as 1 and n as 1 here and down also, what this formula will reduce to? x2 plus x1 upon 2, and again m is 1, n is 1, because if two segments are equal, the ratio will be what? 1:1. So you put it here and you get the midpoint formula, but no need to show this in the exam. You can directly use the formula. So px will be x1 plus x2 upon 2, 2 upon 2. This is known as which formula? Midpoint formula. This is known as midpoint formula. Done with this? Okay, there is one more which we will take it after this, and that is known as centroid formula. Now, the third formula, centroid formula. As you know, centroid is a point of intersection of all the medians of a triangle. So say this is AM, so M will be the midpoint. So this point is known as G. This point is known as G. It is a point of intersection of all the three medians of the triangle. What do I mean by the word median? Median is not a point. Median is a segment. So which starts from the vertex of a triangle and goes and joins the midpoint of the opposite side. So definitely a triangle will have three medians, and there is a property which says that all the three medians of a triangle always meet at a point, and that point is given a special name known as centroid. Now this centroid is a point. This G will divide the median from the vertex side in the ratio 2:1. This is a property. Again, this will be 2:1. Then this will be 2:1. From the vertex side, the distance is more. So if I use that, okay, we can find the coordinates of G, because see, we can find the coordinates of M. M is the midpoint, and then by using section formula, how can we find coordinates of M? Midpoint formula. Then G is the centroid. The ratio is 2:1. So by working out all those things, by using section formula we can derive centroid formula, but the derivation is not there. We are free to use directly the centroid formula, and that is gx is x1 plus x2 plus x3 upon 3, gy is y1 plus y2 plus y3 upon 3. So this is known as centroid formula. Comfortable? So section formula, midpoint formula, and then centroid formula. Now that you are done with all this, we will start with numericals. Question 1. AB is the diameter of the circle with center C. C is given as minus 2, 5. If A is 3, minus 7, find the length of the radius AC. So if you just draw a rough sketch, AB is the diameter and C is given to be the center of the circle, and C the coordinates are minus 2, 5. A it is given as 3, minus 7. Find the length of radius AC. Okay. Now how do we find AC? Distance formula, which you have studied in standard 9th. So in case you have forgotten that, see, the whole topic of distance formula is not there in great detail, but surface level knowledge or direct application of distance formula can very much come in 10th standard fused with these sums, midpoint, section and all, definitely. Now see, Pythagoras theorem is again explicitly not there in the syllabus, but we use it on and off. But a very deep question based on Pythagoras theorem exclusive will not come because it is not categorically there in the syllabus. Okay, so now just to revise your distance formula, if P is say x1, y1, Q is say x2, y2, then PQ will be the distance between the points P and Q, or length of segment PQ will be square root of y2 minus y1 the whole square, y2 minus y1 the whole square plus x2 minus x1 the whole square, square root of it. This was your distance formula. Okay. Now see, we need to find AC. So what we can do, take this as x1, y1, take this as x2, y2. You can mark it for your convenience, no problem. Now this will be what? y2 minus y1. So phi minus 7. Phi minus 7 plus minus 2 minus 3 the whole square. Take care of the signs. This will be now 5 plus 7, 12. 12 square is 144 minus 5 the whole square, 25. Square root sign will not operate independently on each and every term because there is plus. So when there is plus or minus sign, square root cannot operate independently on each and every term. Yes, that is true if it was multiplication or division. Here we will have to add and then take the square root. So square, that comes to square root of 169, that is 13. This completes your first part. Second subpart, coordinates of B. Now you may feel that CA and CB are equal. Definitely, because C is the center. So you take B as x, y or P, Q and try to use distance formula and all that. It will become very, very tedious. The catch in the sum is C is acting as the midpoint of AB because C is the center. So what we do, we say let B be A, B. Okay. Now C is the center. So C is the midpoint of segment AB. C is the midpoint of segment AB. So now midpoint is given, you have to find that. So it is a direct application of midpoint formula. So what I will do, I will write C suffix x. So now C is the midpoint of segment AB. So the extremities, the extreme points, one point will act as x1, y1, other point will act as x2, y2. Now C suffix x will be x1 plus x2 upon 2. But C suffix x is already given. Here the midpoint is already given to you, reverse sum. Rather than you finding the coordinates of the midpoint, here coordinates of the midpoint are already given. So below Cx, we will write minus 2. So it will be 3 plus a upon 2 minus 4. Now solve for a. So a is minus 7. Cy is y1 plus y2 upon 2. Cy is 5. That is minus 7 plus b upon 2. So b is what? 17. So we have found a and b, but we can't leave it here because they said find the coordinates of b. So we have to report the answer in the coordinate form. So b will be minus 7, comma 17. This completes with your first question. Question 2. ABC is a triangle and G 4, 3 is the centroid of the triangle. Okay, so what we'll do, we'll just draw a rough sketch. This is A, B and C. A is 1, 3, B is 4, B and C is A, 1. And G is the centroid, so no need to draw the medians and all, just show this point here G. And the centroid is given now, reverse sum. G is given as 4, 3. You are not asked to find the centroid, that would be like too easy and direct. Here centroid is given, you find the missing coordinates. So what we do is, we take this as x1, y1, x2, y2, x3, y3. Now gx will be x1 plus x2 plus x3 upon 3. But what is gx? Already given to be 4. So below gx you will write 4. So 1, gx is 4, okay. Now x1 plus x2. So 1 plus 4 plus x3, that is a, upon 3. Solve it for a equation. 4 3s are 12. So 12 will equal 5 plus a transpose. A will equal 7. Similarly, gy will be y1 plus y2 plus y3 upon 3. What will be gy? 3. Gy is already given as 3. So it will be 3 plus b plus 1 upon 3. 9 is equaling 4 plus b. B is what? 5. So ultimate G. So we have found A and B. What is required? A and B. That is done. Now what do we need to find? Length of side BC. How will we find length of side BC? By using distance formula. So now B is 4, B. But what is B? 5. So B will be 4, 5 and C kya hai? A, 1. A worked out to be 7. So 7, 1. Now we got the complete coordinates of B and C. So we can find length of segment BC by using distance formula. So this will act as x1, y1. This will act as x2, y2. So first you will have to write the formula, which I am not writing here, and then show the substitution. So y2 minus y1 the whole square plus x2 minus x1 the whole square. So that is minus 4 the whole square, 16 plus 9, that is square root of 25, that is 5 units. So done with this sum. So question 2 is now over. Question 3, diagram is drawn. Point P, the coordinates are already given, minus 4, 2. Now A and B are not some ordinary points. A is lying on x-axis. B is lying on y-axis. Okay. See the ratio. AP is to AB. Keep in mind, AP is to AB is 1 is to 3. So ratio is not 1 is to 3, it's not m is to n. See, P is the point of division. P divides segment AB. So we need this part PA and we need this part PB. So it is AP is to AB. Observe. Observe very carefully. So AP is 1, AB is 3 units, I mean not in absolute terms but in the ratio form. So now this will be taken as 1 and the whole AB is 3. So how much would be PB? 2. So now we can say that point P divides segment AB in the ratio 1 is to 2. Therefore drawing diagrams is essential. If you just start working like this, you will take m is to n as 1 is to 3 and everything will go wrong. Okay. Now what do we need to find? Coordinates of A and B. So A will be x comma 0. Any point which lies on x-axis has the coordinates of the type x comma 0. Any point which lies on y-axis will have the coordinates of the type 0 comma y. Now Px is mx2 plus nx1 upon m plus n. So let's do the initial settings. I am taking this as m. So what should be my x1, y1? This point or this point? This point A. Because I told you in the beginning, m should always go on the side of x1, y1. So this will be now x1, y1 and this will be our n for Nagpur. This will be x2, y2. Now once you do the initial settings, then it is a matter of simple substitution. Px is mx2 plus nx1 upon m plus n. What is this? Section formula. What is Px now? But Px is already given, minus 4. So below Px we write minus 4. Mx2, so 1 into 0. Be careful while substituting. 2 into x1. So that is x upon m plus n. So 1 plus 2 is 3. 3 into minus 4, that is minus 12. Minus 12 is equaling 2x. X is minus 6. So what would be the coordinates? Now okay, we'll write it in the later. Let's go for Py. Py will be my2 plus ny1 upon m plus n. Now Py is already given here, that is 2. So that is now my2, so 1 into y, just substitute, plus n into y1 upon 1 plus 2. So 1 plus 2 is 3, 3 into 2, I am continuing up, 1 plus 2, 3, 3 into 2, 6. So 6 is equaling y. Okay, let's check once again. py is my2 plus ny1 upon this. Okay, done. So y is equaling 6. So now we need to find the coordinates. So how much is a coming out to be? X comma 0. What was the value of x? Minus 6. So a will be minus 6 comma 0. B is what? 0 comma y. Y turned out to be 6. So B will be 0 comma 6. The coordinates of any point should be written always in round brackets because it is an ordered pair. No brace brackets, no box brackets. You will definitely lose the marks because it changes the whole sense of reporting the coordinates. Now we are done with question 3. Question 4. Given a line segment AB. Line segment means segment, which is different from a line. Joining the points A minus 4 comma 6 and B 8 comma minus 3. Okay, so we'll just draw a rough sketch. This is A minus 4 comma 6 and B 8 comma minus 3. Find the ratio in which AB is divided by the y-axis. So y-axis, you know, vertical. So what they are trying to say is if you plot these 2 points on a graph paper, okay, y-axis will be cutting segment AB in some ratio and we need to find that ratio. See, in the previous sum the ratio was given. Here we need to find the ratio. Fine. Now this we take it as suppose x1 y1. Here we take it as x2 y2. Kindly note, in section formula order matters a lot. See, in midpoint you take x1 y1, x2 y2, or you take ulta, doesn't make a difference. Even in centroid, you know, when you take a triangle, any vertex you can take as x1 y1, second one you take it as x2 y2, third you take it as x3 y3, or third vertex you take it as x1 y1 and then start, no problem. But here is not like that. Okay, let this be some point P. Y-axis is cutting this segment AB in some ratio, this ratio. So let this point P. Now point P lies on which axis? Y-axis. So the coordinates will be of the type 0 comma y. Let the ratio be m is to n. Let the ratio be m is to n. Note, m should be on the side of x1, y1. Okay. Now with what to start? Px or py? Start with px here. The reason is px is known to us. It is 0. If you start with py, the y coordinate, it is y. That is unknown. On top of that, ratio is also unknown. So there are too many unknowns. So start with px in this case. So px will be mx2 plus nx1 upon m plus n. What is px? 0. So below px we write 0. mx2, m into x2, m into 8 plus nx1 plus n into minus 4. Instead of putting multiplication, use brackets here. It will look neater and better to understand also. Upon m plus n. Now what to do? Cross multiply. What is our target? Find the ratio in which. That means we want to find m is to n. So it is not necessary that we find m, then we find n separately. We just want to find m is to n, directly the ratio. Cross multiply, m plus n into 0, 0. Anything into 0 is 0. So 0 is equaling 8m minus 4n. Minus 8m is equaling minus 4n. So minus minus will balance each other. So 8m is equaling 4n. Now m upon n will be 4 upon 8 or 8 upon 4. Observe, It will be 4 upon 8. In case you have some doubt, cross multiply and see. You should get the previous step. 8 into m is 4 into n. Yes, we have got it. In case you wouldn't have got this, I mean, if you written 8 upon 4 and when you cross multiply, you will not get the previous step, indicating that you have made some mistake. So this will be 1 upon 2. But they have said find the ratio. So we have to report it in the ratio format. So we would write m is to n is 1 is to 2. Comfortable with this? We have not yet completed the sum. This is just the first sub part. Now we will see how to get the second sub part. Sub part 2, the coordinates of the point of intersection. So y-axis and AB, they meet at point P. So that is already 0, y. But then this y coordinate is not known. So first we found the ratio. Now we will find the y coordinate. So Py will be my2 plus ny1 upon m plus n. What is Py? Y coordinate. Py means what? Y coordinate of point P. What it is in this case? Y. So below Py you write y. my2. Now what was the ratio? 1 is to 2. So we can take m as 1, n as 2. So 1 into y2 plus n into y1. So this is now minus 3 plus 12 upon 3. So 12 minus 3, 9, 9 upon 3, 3. Okay, so y is 3, but we need to find the coordinates of the point of intersection, that is 0, y. So that is 0, 3. This completes your question 4. Calculate the ratio in which the line joining A 6, 5 and B 4, minus 3 is divided by the line y equaling 2. Also find the coordinates of the point of intersection. This is not y-axis, this is a line y equaling 2. So in case you have forgotten some basics, let's have a quick recap. This is say 0, 1, 2, 3. This is 1, 2. This is minus 1, minus 2, 1, minus 1, minus 2, minus 3 and so on. If I draw a line like this, parallel to x-axis, then this line, the equation of this line will be y is equaling 1, ulta. If a line is parallel to x-axis, equation will be y equaling 1. Okay, it depends from where it's passing, but the line should be parallel. If it is passing like this through minus 2 and parallel to x-axis, then we say the equation of this line is y equaling minus 2 or y plus 2 equaling 0. Similarly, if I draw the line like this, parallel to y-axis, if I draw a line, say L1, parallel to y-axis, then the equation will be x equaling something. So here equation will be x equaling minus 2. Now, if you observe, let's take the line y equaling minus 1. Take any point. Take any point on the line y equaling minus 1. What would be the x coordinate? We don't know. It can fluctuate, but y is 1. The height is fixed, but the x coordinate can go anywhere to the left or right. So any point lying on the line y equaling 1 will have the coordinates of the type x, 1, where x is varying, but y is fixed. Similarly, if I come on this line, x equaling minus 2, any point on this line can go up, it can go down, jumping. So y coordinate is not fixed, but the x coordinate is fixed. So any point lying on this line will have the coordinates of the type minus 2, y. So this way many modifications can be made for this sum. Now let us see, after having discussed the fundamentals, how to go about this question. Calculate the ratio in which the line joining A 6, 5 and B 4, minus 3 is divided by the line y is equaling 2. So what we do is we take A as 6, 5 and B as 4, minus 3. We take A as 6, 5 and B as 4, minus 3 divided by the line y equaling 2. Y equaling 2 will be a line parallel to x-axis, ulta. So y equals, say, x equaling 2 will be a line parallel to y-axis. Y equaling 2 will be a line parallel to x-axis. So then we will draw it like horizontal. Let this point be, say, P. What would be the coordinates of P now? Y is 2, but the x coordinate is unknown. So the point can swing anywhere to the left or right. So it will be x, 2. P will be x, 2. They can modify this sum. They can give you y minus 2 equaling 0. So don't think y is minus 2. You always make y as the subject of the formula to get a clear picture. Okay, now we want to find the ratio. We take this as x1, y1, this as x2, y2. And point P is dividing segment AB in some ratio. So it is this is to this. So let this be M and this be N. Because what did I tell you? M should be on the side of x1, y1. Okay. Now that we want to find the ratio, with what should I start? Px or Py? Py in this case. Because if you start with Px, Px is unknown, that is x. X coordinate of P is x, unknown. Ratio is also unknown, so too many unknowns. So you start with Py. So Py will be my2 plus ny1 upon m plus n. Now what is Py? 2 already. So now m into y2. So m into minus 3. Now it is simple substitution. N into y1, that is 5 upon m plus n. Now just cross multiply. Minus 3m and transpose. So collect all m terms on one side and n terms on other side. That is a trick. Now m upon n will be what? 3 upon 5. If you have a doubt, cross multiply and see. You should get back the previous step. If no, then just interchange. But they have asked the ratio, so we will have to put it in the ratio format. So m is to n will be 3 is to 5. And this completes the first part. Calculate the ratio. Question also says, also find the coordinates of the point of intersection. That means we will have to find the complete coordinates of P. So Px will be mx2 plus nx1 upon m plus n. Now what is Px? X. So below Px, I mean, we will have to write x equal to, because the Px means what? X coordinate of point P. Here we have taken it as x. So it will be x equal to mx2. Now m we know, ratio was initially unknown, but now we know it. So it will be mx2. So that is 3 into 4 plus 5 into x1 upon 3 plus 5. I will have to erase that part. let's see what this works out to be. 12 plus 30, 42, 42 upon 8. So we'll have to simplify 21 upon 4. Now you can put it in decimal if it is terminating decimal, otherwise this is fine. It is an improper fraction, but improper fraction should be in the simplest form. Okay, in any topic, improper fraction should always be written in the simplest form. Yes, if it is a topic of similarity, then you'll have to give it in the mixed fraction format and all that. But in coordinate geometry, the coordinates when you are reporting, it is fine if it is in the improper fraction, but it should be simplest improper fraction. So now P will turn out to be 21 upon 4, comma 2. So done with your question number 5. Question 6 and the final question of this topic. Show that P 3, m minus 5. So m minus 5 is a single entity. This is the x coordinate, this is the y coordinate. Is a point of trisection of the line segment joining the points blah blah blah. Hence find the value of m. Now let's see this concept of trisection before we solve the sum. Suppose if you have segment mn and you need to divide it into 3 equal parts. So how many points will be required? 2. One point will be here, say A, other point will be here, B. And the 3 parts are equal. So say they are 7, 7, 7. They are equal, whatever. So in what ratio will A divide segment Mn? 7 is to 14. So what is the ratio? 1 is to 2. But then this point is also responsible. 2 points are required to divide the segment into 3 equal parts. Now this point, if you see, point B divides segment Mn in what ratio? This is to this. So that is 14 is to 7. So that will be how much? 2 is to 1. Effectively, this means if you want something as a point of trisection, then the ratio should work out to be 1 is to 2 or 2 is to 1, depending upon where the point is placed and nothing else. So based on this, we will have to solve this sum. Segment AB, A is given, B is given, x1, y1, x2, y2. P is given as 3, m minus 5. So what is the ratio? M is to n. The ratio is m is to n. So m will go on this side, on the side of x1, y1. Now I am taking capital M because small m is already used there. So to avoid any confusion, and here we will use capital N. Formula, everything remains the same, but just we are replacing small m and small n by capital M and n. Okay, since we want to find the ratio, judge and tell me, we should start with Px or Py. Px here, because Px is known. If you start with Py is unknown, ratio is also unknown, too many unknowns. So but what are the initial settings? M should be on the side of x1, y1, which it is. So Px will be mx2. Now remember to write capital M, plus nx1 upon m plus n. What is Px? 3. So below Px we write 3. mx2 now, m into x2. So m into 1 plus nx1, this is mx2 plus nx1, n into 4 upon m plus n. Now cross multiply. Three m plus 3n is equaling m plus 4n. 2m is equaling n, 4n minus 3n. So m upon n will be what? 2 upon 1 or 1 upon 2? 1 upon 2. Cross multiply and see, you should get the previous step. So m is to n is 1 is to 2. So we have found the ratio m is to n is 1 is to 2. So therefore definitely point P can act as a potential point of trisection because the ratio is coming out to be 1 is to 2. So P would be like closer to A than it is to B. This sum can be modified and maybe you will get the ratio 2 is to 1 if I change some coordinates here. Then also P will be the point of trisection. So remember, if you want to prove anything as a point of trisection, just work out the ratio. If the ratio works out to be 1 is to 2 or 2 is to 1 by correct method, then that point can be called as a point of trisection. Now what else is remaining? Hence find the value of m. So that we will now find. Now remember, the ratio is 1 is to 2. Now we want to find the value of m also. So we'll have to catch hold of this py. Py will be my2 plus ny1 upon m plus n. Remember to write capital for the ratio. What is py? M minus 5. So below py we write m minus 5 is equaling 1 because the ratio what we found out previously was 1 is to 2. So it is simple substitution, 1 into 4 plus ny1, 2 into minus 2 upon 1 plus 2. Now solve for m. 1 plus 2 is 3. Cross multiply, you will get 3m minus 15 is equaling 4 minus 4. So 3m minus 15 is 0. 3m is 15. So m is 15 upon 3, which is 5. So we have now found the value of m. This completes with your question number 6, and this topic of section formula now stands complete.